Hi everyone. As I mentioned in the earlier video, we will try to show some image on the screen. Okay, so I will open the Visual Studio Code. So currently, I have kept a image. Okay, so here if I go to my application folder, I have the JPG image. Okay, so where we have one bird and then we have the flower. Okay, but our GOP understand the BLT format, right? Where it knows only about the RGB color. Okay, so that's where we need to convert this PNG image to our BMP file format. Okay, so we have a simple Python script to do that. So where we are going to import the image from the PIL, and then we will convert to an RGB format, which is ultimately a BMP file format. Okay, so now I have converted this offline. Okay, so here we have this image, which is a PNG, JPG. PNG, JPG, both are approximately same in our case. And then we have this BMP image where it shows the exact same type. Okay, but it's in the BMP format, which our GOP understands. Okay, so now to show in our application, we need to store that image somewhere in our bias image, correct? So here we have our GOP sample driver. So here I'm going to include. Okay, so it's a file. Okay, so it's a type of freeform. Okay, and then it will contain some GUID. For now I will just type GUID and then we will add the GUID later. Okay, so section, and it's a raw data which we wanted to store. Okay, so now where is our image, which is this one, script.bmp. So I will copy this path and then I'll paste it here. Okay, so I will replace this slash with the other slash. Okay, so now we need to have the GUID, right? So I will go to the deck file and here we have our GUID section. Okay, so here I will create a new GUID. Okay, Control Shift F, insert GUID, and then I will print the GUID name. And here probably let's write some name, right? So probably I will call this as a G background image GUID. Okay, and now so this is a GUID which I'm going to use it here. Okay, so now we have the GUID ready. So now we need to include in our application, right? So here I will go back to our INF file. Okay, here I'm going to have the section header called GUIDs. Okay, so now we have our GUID now. Okay, so now it needs the Dixie services to get that binary from the bias firmware image to our application. So I'm going to use the Dixie service library. Okay, and then we have that BMP image, right? So that image we have to convert it to an GOP buffer, right, which is a BLT buffer. Okay, so to do that we need a translation layer, which is BMP support lib. Okay, so now if I search this BMP support lib, here it is coming from the MD module package here. Okay, so I will copy this library. Okay, and now this my emulator package does not have that. Okay, so now I will paste it under the library section. Okay, and now what we did, so in the deck file we have created a GUID. In the DSC file we have added the BMP support library, and in the FDF file with this GUID we have stored our bias binary. We have stored our image in the bias binary, and in the INF file we just included the GUID and we have included some libraries. Okay, so now the next step is let's include the required header files. Okay, so now we are going to use the Dixie services, right? So we mainly need pi dixie.h, Dixie service syslib.h. Yep. Okay, And now we need to convert that BMP to GOP BLT, right? So we need to have this BMP support library as well. Okay, so which is located under the library. Include library BMP support library. Okay, so now we have the required things ready. So now let's locate that bias binary and then we will convert it to GOP BLT. So I will reduce the timing from 2 seconds to 1 second here so that we don't lose the earlier code. Okay, so now we need some variables. Okay, so now let's create the variables which it is needed. Okay, so now um, here I will go back to this here. We need to use this API translate GOP BLT. No, we need to use this one. Okay, so we need to use the BMP to GOP BLT. So BMP is our image and we are going to convert it in GOP buffer. Okay, so probably now I'm going to copy from here and then we will remove the one which are not needed. Okay, now semicolon. Okay, so we got the BMP image data. We have the image size. Okay, and then it is going to contain the BLT. So now let's remove this. For now, it is not needed. Okay, so now here these and all the pointers. Probably it is not needed for now. Okay, so now we need to store that pixel information, right? Which is the background information. So let's call this EFI graphics BLT output pixel. Okay, so now in this pixel we are going to store the background to BLT. Okay, background BLT which our image is going to have. And then we have the event end, so we need to know what is the size of this buffer, right? So background BLT size. Okay, so then I will create the another two variables to hold the background height and width. Okay, so background height, width. Okay, so now we have the required variables. I will initialize the size to 0 and this is by the way it is out variable. Okay, so now let's call our API. Okay, so now this is the API which we are going to call. Okay, so translate BMP to GOP BLT. Okay, so now the first argument what we need, sorry, before we call this API, right, we need to get that image from the binary. Okay, so status is equal to get section from any FV. Okay, so we are going to get the section. Okay, so now we need to pass, so this API is going to take the name, type, instance, buffer and the size. So this buffer and the size are the output variables. Okay, so ultimately we need these three arguments. Okay, so now what is the this image, right? So this GUID we have to pass. Okay, so ampersand GUID we are going to pass. Okay, so now it's a type of an section, it's a raw binary, right? So that now we need to pass the section, right, which is a raw binary. So let's pass it EFI underscore section. It's a raw binary. And the third argument, we don't need it. And now we have the output variable, right? So that output variable, we are going to have this BMP image and the BMP size. Okay, so it's out variable and then we have the BMP image and the BMP image size. Okay, so now if this image is, if this GUID is not available, we have to, we should not proceed further. Okay, so if there is any error in the status, okay, so then we will simply return the status. Okay, so now we are going to call the API. Okay, So now status is equal to, so we are going to convert this BMP to GOP BLT. Okay, so now the first data what it needs is the image and the size. So now the image and the size we already located here. So we will pass the same argument. Okay, so we will pass the image and the BMP image size. Okay, and now the next argument is the BLT buffer, right, which it is going to return. Okay, so now so we have this BLT buffer which we have initialized here, which is background BLT. Okay, so we will pass this background BLT to the API. Okay, and now it's an address. Okay, and now so that background BLT size, right, so how much size it has to allocate. So we have this one here, how much it has allocated, right? So again address this one. Okay, so now what is the next argument? It is going to contain the pixel height and width, so that whatever the image which we have, right, so it is going to return the image height and width to us. Okay, so now what is the arguments we have? So it's a background height and background width. Okay, so I will align the document. So now, so in my case, if I go back to emulator package, application, GOP sample driver. So this image, right? So it's a exact size of 1024 into 768. So it's a one which we have the mode set, right? So this is the resolution which we have set. In this, that's the reason I'm using that same height and width to fill the entire screen with this image. Okay. So now here, now we have converted this BMP image to our GOP BLT that is stored in this background BLT. Okay, so now we have to fill it, correct? So now let's copy this API, GOP BLT API, and we will pass the required arguments to it. Okay, so now here the second argument, right, which is going to, earlier it is pointing to the buffer. Earlier we used to print the color, now we have to print the buffer. Okay, so now buffer is nothing but our background BLT. Okay, so I will pass the direct background BLT. Okay, so now earlier we used to use this video fill, right, where this video fill, not this, graphics output. Okay, so now this video fill, right, to where our source x and y is always going to take 0, right? So that's the reason in the earlier we used to use this 0 0. Okay, so now we know what is the buffer which we have to print. Okay, so now this is a buffer, and that buffer we have to fill it to the screen. Okay, so now we have to give the explicitly source and destination if it is needed. Okay, so now here we are not going to use the 00 for the source and y, or we can use it, right? But we know that we need to translate the this background BLT to the screen. Okay, so EFI BLT buffer to the video, and now we will start with the top left corner 0 0, and the destination also we will give it to now destination also it's a 0. Okay, and x and y are 0, so which means we are going to start our buffer, and we are going to start our destination from the top left corner. Okay, and then the width, right, so the width is our the one which we have given above. Okay, so now the image height and the width. Okay, so here width. Okay, so now the height I will pass it here. Okay, and then height also, the width also I will pass it here. Okay, so we have the height and we have the width. Okay, so now I will format the document. Okay, so now what we did, so we got the raw binary which is a BMP image, and that BMP image we have translated to the GOP BLT. and that gob blt we will start with we will start with 0, and then we will print the height and width of this image, the entire screen. Okay, so now let's run it. EDK setup, build. Okay, okay, so we got the error here. So in the deck file looks like it's a invalid GUID format. Let's go back here. We have our here, and yeah, so here we have the semicolon, right? So the semicolon is not needed. So now let's build it again. Okay, so now it says Dixie service lib is not found. Let's see. Looks like there is a spelling mistake. Dixie services lib. Okay, so here Dixie services lib, and above also we have the Dixie services lib. Yes. Now I will build it. Okay, so now we will run our WinHost, build x64 debug x64 WinHost. Now we will run the driver gop sample driver. Okay, nothing happened. So now here we will see background image. Here we have this background image. In FFS also we have the background image. Still it did not print it. Let's go back to our code, and here we have this microsecond delay. We have this section, and yeah, let's try to print the status here, right? So debug underscore info percentage r slash n, and then we will print the status. Okay, and that same status here also we'll try to print it. Let's rerun again. Okay, so we'll run again. Gops sample driver. Okay, so now we got the buffer too small. Okay, so now let's go back to our buffer, which is this BMP. Sorry, the second buffer, right, which is this one. Okay, so either we have to do the allocate pool of this height and width, or we can initialize this BLT buffer to null. Okay, so now let's build it again. Okay, so now here WinHost gop sample driver. Yep, now we can see our status is success, and now we got our pixel information at the height and width of those pixel information along with the header, and this is what we got our image. Okay, so now in the next video we will try to understand about the mouse cursor within our display. Okay, yeah, so that's it for today. Thank you.